Picture this. You're an economist working for a major corporation. Your job is to predict future sales based on multiple factors like marketing spend, competitor activity, and economic indicators. How do you do this? Enter multiple regressions. Imagine multiple regressions as the Swiss Army knife of economics. It's a statistical tool that allows us to estimate the relationship between multiple independent variables and one dependent variable. For instance, you can analyze how both the cost of production and advertising budget impact the sales of a product. Why is this important? Well, it gives economists the power to not just observe but predict and plan. It provides a way to quantify the impact of various factors on a specific outcome, making it a critical tool in decision-making processes. So, by the end of this video, you will be able to explain what multiple regressions are, describe how they are used in economics, and apply them to a real-life scenario. Think of multiple regressions as a detective tool in economics, helping you uncover the relationships between different factors. Let's delve into the fundamentals of multiple regressions. To start with, we have variables. Now, variables are just elements or factors that can change or vary. In multiple regressions, we have two types of variables: independent and dependent. The independent variables, also known as predictors, are the factors we believe might influence something else. The dependent variable, on the other hand, is the one we think is influenced by our predictors. Picture this. If you want to predict the price of a house, the size of the house, location, and the number of rooms could be your independent variables. The price of the house, which you're trying to predict, is the dependent variable. Next up, we have coefficients. Coefficients are the numerical values that multiply the variables. They tell us the degree to which each independent variable affects the dependent variable. For instance, in our housing example, the coefficient of size tells us how much the price changes with each additional square foot of space. Then we have the error term. Despite our best efforts, there will always be some factors we can't account for. And that's where the error term comes in. It's a catch-all for everything we've missed. These elements, the independent and dependent variables, coefficients, and the error term, interact within a multiple regression model to give us a mathematical equation. This equation can help us predict the dependent variable based on the values of the independent variables. So, we use multiple regressions to analyze the relationship between one dependent variable and multiple independent variables. This allows us to understand how each independent variable impacts the dependent variable, while controlling for the effect of other variables. In essence, it's like a puzzle. Each piece, or variable, has a role to play in the bigger picture. And the beauty of multiple regressions is that it allows us to see how these pieces fit together. So, multiple regressions help us understand how a set of variables affect another variable. Pretty handy, right? Now that we know what multiple regressions are, let's dive into how they work. Imagine being a detective, but instead of solving crimes, you're deciphering the relationships between various factors in an economic model. That's what running a multiple regression analysis is like. First, we need to collect data. This is the backbone of our analysis. It could be anything from unemployment rates to GDP, or even the number of ice cream cones sold on a sunny day. The more robust and varied your data, the more comprehensive your analysis. Next, we set up our regression equation. This is where we identify our dependent variable, the one we're trying to predict, and our independent variables, the factors we think might affect the dependent variable. Here's where it gets interesting. We run the regression, and our software churns out a host of numbers. Among them are the coefficients for each independent variable. These coefficients tell us the expected change in the dependent variable for a one-unit change in the independent variable, all else being equal. For example, if we're looking at the effect of education on income, and the coefficient for years of education is $2,000, this suggests that an additional year of education is associated with an increase of $2,000 in income. But wait, we're not done yet. We also need to pay attention to the error terms. These represent the difference between our predicted values and the actual values. Smaller error terms mean our model is doing a good job at predicting reality. Interpreting these coefficients and error terms correctly is crucial, as it helps us understand the relationships between variables. And it's not always as straightforward as it seems. Multiple regression analysis allows us to control for several factors at once, giving us a richer, more nuanced understanding of our economic world. Just remember, the power of multiple regressions lies in its ability to tease apart the individual effects of multiple variables. Now, let's bring multiple regressions to life with a real-world economics example. Imagine you're an economist tasked with predicting the gross domestic product, or GDP, of a country. You know that several factors can impact GDP, like the labor force, capital stock, and technological advancement. But how can you model these relationships to make an accurate prediction? That's where multiple regressions come into play. Think of the labor force, capital stock, and technological advancement as independent variables. Each of these can influence the dependent variable, which in this case is the GDP. Now, the goal is to construct a regression model that best fits the observed data. Let's start with the labor force. It's logical to assume that an increase in labor force might lead to an increase in GDP. We would express this relationship in our regression model with a positive coefficient. This coefficient quantifies the expected change in GDP for each unit increase in labor force, holding all other variables constant. Next, consider capital stock. This includes things like machinery, buildings, and equipment. Similar to labor force, an increase in capital stock can also boost GDP, so this relationship would also be represented by a positive coefficient in our model. Lastly, we have technological advancement. This factor can significantly influence productivity and hence GDP. The more technologically advanced a country is, the higher its GDP might be. So again, we would expect a positive coefficient. By running multiple regressions, we can estimate these coefficients and create a model that can predict GDP based on changes in labor force, capital stock, and technological advancement. Remember, in real-world economics, things can get quite complex. There might be other unobserved factors at play, and the relationships might not always be linear. But that's the beauty of multiple regressions. They provide a starting point, a simplified model that captures the key relationships among variables. In the hands of a skilled economist, multiple regressions become a powerful tool for making accurate predictions and informed decisions. Now it's time to put your knowledge to the test. Firstly, let's imagine we're working with a dataset where we're trying to predict a country's GDP. We have variables like inflation rate, unemployment rate, and interest rate. Can you tell me which regression model would be the best fit here? Is it A. Simple linear regression, B. Multiple linear regression, C. Polynomial regression, D. Logistic regression? The correct answer is B. Multiple linear regression. We're dealing with multiple independent variables that could potentially impact the dependent variable, which is GDP in this case. Next, consider this. If we add more variables to our multiple regression model, what happens to the R-squared value? Does it A. Increase, B. Decrease, C. Remain unchanged? D. It can't be determined. The right answer is A. It increases. The R-squared value represents the proportion of the variance for a dependent variable that's explained by an independent variable or variables. So when we add more variables, the R-squared value generally increases. Thirdly, let's look at multicollinearity. If two or more variables in a multiple regression are highly correlated, what issue does this cause? Is it A. It makes the coefficient estimates unstable, B. It reduces the standard error, C. It improves the fit of the model, D. It has no impact on the model? The correct answer is A. It makes the coefficient estimates unstable. Multicollinearity can inflate the variance of the regression coefficients, making them unstable. Finally, let's think about the importance of the F-test in a multiple regression analysis. The F-test is used to determine A. The overall significance of the regression model, B. The significance of individual coefficients, C. The correlation between variables, D. The variance of residuals. The right answer is A. The overall significance of the regression model. The F-test checks if at least one of the predictors has a non-zero coefficient. Well done! You're now well on your way to mastering multiple regressions in economics. Keep practicing, and soon enough you'll be making predictions like a pro. As we wrap up, remember that multiple regressions are just one tool in an economist's toolkit. It's a powerful instrument, helping us decipher complex relationships between variables, but it's just a piece of the larger puzzle. We've journeyed from the basics, understanding what multiple regressions are and their foundational concepts. We delved into the mechanics, dissecting how they work and how to interpret their results. We also explored their real-world applications in economics, seeing firsthand how they shape decision-making and policy. But don't stop here. Continue to explore multiple regressions in different scenarios. Practice makes perfect, and the more you use them, the stronger your grasp will be. Perhaps even come up with your own real-life scenarios and try to apply what you've learned. The world of economics is full of mysteries waiting to be solved, and with multiple regressions, you're well equipped to tackle them. So keep exploring, keep learning, and keep asking questions. The sky's the limit.